The following question is about two-dimensional motion of a block along a surface. So let's see what the question tells us. So it tells us that we have a block of mass 10 kilograms, and at time equals 0, a person pushes it to the right with a time-dependent force. So the force is dependent on time. It's a function of time. And it's equal to AT plus B, where A is 7 newtons per second and B is 30 newtons. We also know that there's a coefficient of friction between the surface and the block, which is equal to 0.200. So what we're tasked to do is find the acceleration and velocity at 1 second. So in order to do this, let's start off by drawing a free body diagram. So to draw a free body diagram, let's simulate it by drawing this block right here and giving it a center. So we're moving it to the right. This person is pushing it to the right with a time-dependent force equal to AT plus B. We also know that there's gravity between the block and Earth. So we have the weight of the block, which is equal to mass times gravity. We also know that there's a surface between the block and the Earth. So we know it's not falling, so there's a normal force. We're going to represent that by force of normal. And force of normal is also equal to the magnitude of the weight that we have in this situation only, since we have no forces actually pushing upwards. And now we know that there's a force of friction going against the force of the push, and that is equal to the coefficient of the friction times the magnitude of the normal force. So that's our free body diagram. So if we want to find the acceleration at t equals 1, we have to go back to the equation that we had before, which was F equals ma. We know that is true. Now, we know that we have a force for function, and we have a free body diagram telling us which forces are working on the box. So, if we want to find acceleration, then we can just do F over m is equal to a. Now, what you don't want to do is just say that this force is AT plus B and divided by the mass that we have. This is because we have a coefficient of friction working on the box. The surface is not frictionless. So what you actually have to do is have the total amount of force. So that means we have AT plus B minus, because we have friction working in the opposite direction to the left, the coefficient of friction times the normal force, which is going to be actually the mass and then times the acceleration of gravity. And this is all going to be divided by the mass that we have, and this will give us acceleration. So if we do this and we calculate it, we get A is equal to A, which is we have right here is 7, times t at 1, plus B, which is 30, minus the coefficient of friction, which gives us 0.2, the mass that we're given, which is 10, the acceleration of gravity, 9.8, and then we have it all divided by the mass that we were given, which is 10. And this gives us an acceleration of 1.74 meters per second squared. So that's how you set it up. Now, we got to find the velocity at t equals 1. Now, if we were to do this, how we would set it up is we would try to convert whatever our acceleration is into velocity. Now, we do know that acceleration is the derivative of velocity, right, with respect to time. That must mean that a velocity function of time is equal to the integral of acceleration with respect to time. That means we're going to plug in the equation that we had for acceleration into this integral. And so we would get actually the integral of AT plus B minus the coefficient of friction times the mass times the gravity, which is this is supposed to represent the normal force, all divided by the mass, and this is with respect to time. So if we do that integral, what we do end up getting is velocity is equal to a 1/2 AT squared, because if you do the integral on t, you go to the second power and then divide by 2, plus b times t, since it's a constant, you add a t to it, and then minus the coefficient of friction times mass times gravity times t, all over m, which is a constant. And then we have a plus c. We have a constant, since this is a general integral. It's not a defined integral. Now, this constant is also equal to the initial velocity that we have. Now, if you remember that at t equals 0, that's when the person started pushing. So that means that the initial velocity was 0. So that means v of 0 is equal to, and we also know that v of 0 is just plugging in 0 for all these functions. So all these would be 0, and then all we have left is c. So putting these two together, we know that c is equal to 0, which means that our initial velocity was also equal to 0. So all that we have left is just this part of the equation. So if we plug in v of 1, which is time equals 1, we just get 1/2, and then a, which is 7, t squared, so we have 1 squared, plus bt, which is 30 times 1, minus the coefficient of friction, which is 0.200, times mass times gravity, so we have 10 and 9.8, times time, which is 1, all over mass, which is 10. And this gives us 1.39 meters per second. So that's how you set it up. So this is two-dimensional motion where we have not only just a force, which is actually a function of time, so it's increasing as time goes on, but we also have a coefficient of friction working against it.